Welcome to another one of my exciting videos. And in this video here, I will not be going through every single possible thing you need, but I will provide you with a little more information about this building than you might have had if you didn't watch the video. To build a 4-unit apartment, or quite possibly 4 units you might be able to sell with my tiny home design. Now, I will be putting a link in the video description box for those of you interested in a little more information on how to build the individual unit. And I would definitely recommend watching that. So not much to it here. We're going to have a solid concrete foundation. It's going to go all the way through. And we are going to have a 2-inch gap in between each one of the units. And the reason for that will be to reduce the amount of sound that can travel between units. So I wouldn't make any framing connections in between the wall framing and the floor framing on the interior. However, on the exterior, you can connect the units together all the way through. So something like this will make it a little structurally stronger than something like this. So let's go ahead and zoom in on that. So as long as I extend the framing plate through by at least 4 foot, I like 4 foot, even though some people are suggesting that only a few inches is enough, and I totally disagree with that. So if possible, extend it at least 4 feet. If not, something is going to be better than nothing. And as I mentioned in the original video that I made for the individual unit, you will need to check with your local building codes to make sure that this stairway is going to work. And as always, I would suggest checking with them on the entire project. And the roof trusses are going to be spaced 24 inches on center all the way through, along with the possibility of at least one firewall in the center of this building that would be installed from the ground up all the way to the bottom of the roof sheathing. And you will need to put in your ceiling backing along with all the building hardware and blocking at the exterior wall and at the roof ridge and on the other side. And I'm not going to bother putting the fascia board on or the roof sheathing because I have drawn it in so many times. I have so many videos on the fascia board and the roof sheathing. And to find those videos, go to the website, click on the building tab at the top, and then scroll down until you find house building projects to find some of the projects I've already completed. In this video, I want to talk about basement waterproofing and provide you with something that I've always been concerned about, even though I live in Southern California where there are not a lot of basements. And that will be the waterproofing of the interior of a basement wall if the exterior waterproofing has failed and you now have water leaking through the walls. And you're not interested in excavating the soil around the perimeter of your home to fix it the right way. And I say the right way because I strongly believe that by waterproofing both sides of a concrete or block wall, you're going to end up trapping moisture. And I've seen plenty of concrete products damaged that weren't ever waterproofed on either side, yet exposed to moisture for long periods of time. And if this leads to structural damage that cannot be fixed, then plan on partially or completely replacing the basement. And that's my main concern in this video, is that these painted on or firmly attached products either don't work well enough to solve your problem, or they work too well and trap moisture. And another problem you need to think about is that these interior waterproofing paints and membranes usually don't last forever. Expect them to break down eventually, and if that happens, they will need to be reapplied, which can be costly and inconvenient for homeowners, especially if you added a framed wall that has been drywalled so that you could finish your basement, adding even more cost to your project when you have to remove the wall so that you can reapply the products. Now let's be realistic. Forget those miracle cure products that promise to magically fix crumbling concrete or gaping cracks. In my experience, they simply don't deliver long-term results. And here's a critical factor many do-it-yourselfers don't know about, and that's the fact that concrete constantly expands and contracts with temperature and moisture changes. That means any rigid paint or membrane you applied is destined to fail. If it can't flex, it will crack and peel, leaving you right back where you started, or worse, like I already mentioned. And now for the big question, how would you fix something like this without spending a lot of money? And I don't really have a good answer. It seems the best way to fix this is from the outside. However, if anyone out there has a better suggestion, feel free to share it with us in the comment area. Here is another viewer-requested video. They were having a difficult time finding the span charts that can be used to calculate the floor joist sizes. So let's go ahead and go over to Google. And you don't have to use Google. You can use other search engines. And we're simply going to type in floor joist span charts. And that's going to take us to the building code books. Now, these are the most common building codes used, and this is their website here. I'm going to click on this one instead of this one, but I would imagine you could click on this one too, or you could probably click on a couple of the other ones down here to find something similar. So again, we're going to click on this, and that's going to take me to this. And I would definitely recommend reading some of this information if you don't know a lot about using span charts. Now, the first one here has a 30 pounds per square foot load on it, and that might be fine, and you might want to compare the sizes of the lumber to the next span chart, but most of the time we're going to be dealing with a 40 pounds per square foot live load for residential home framing. Now, another thing I want to point out is that we're going to be dealing with different lumber. Where I'm at, we deal with a lot of Douglas fir. However, you might be dealing with southern pine or even other types of lumber. Now, let's go ahead and go back up here. And in this column here, we're going to have the joist spacing. 12 inches on center. If I go down, 16 inches on center, and you can go down to 19.2 and 24 inches on center. And then, of course, we have the type of lumber here. And then we're going to have two different columns where we have a dead load of 10 pounds per square foot and another one with 20 pounds per square foot. And then we're going to have the maximum floor joist spans. These are not the minimum. This is the maximum length that this material can span. So at 12 inches on center, Douglas fir number 2, and I doubt if you're going to find Douglas fir number 3. And of course, the most common one here is going to be number 2 or better. And the same thing down here with the southern pine and the hem fir. So this is the number grade of the lumber. Species, Douglas fir, grade, number 1, number 2, and number 3. So if we go to the Douglas fir number 2, you can see where a 2x6 maximum span length is going to be 10 foot 9 inches, spaced at 12 inches on center, 14 foot 2 inches for a 2x8, spaced at 12 inches on center. And of course, we can go right down the list for 2x10, 2x12, and then head over to this side here if we're going to be dealing with a dead load of 20 pounds per square foot. Next up, let's take a look at the most common, which is going to be 16 inches on center, Douglas fir number 2. And then if you remember, this is 2x6, 2x8, 2x10, and 2x12. So again, the maximum span lengths at 16 inches on center. If I'm dealing with southern pine number 2, I'm just simply going to go down here to find the maximum span length. And hopefully that makes sense. And keep in mind that this information here is not meant to provide you with structural engineering information for your home. And I am not a structural engineer. This is just meant to provide you with information on how to use a floor joist span chart. In this video, I will be providing you with a little more information about blocking and bridging, and when you might choose to add it to an existing floor to help with bouncing or sagging. And you need to understand that these simple techniques can indeed improve floor stability, but it's also crucial to understand their limitations, especially in older structures. Basically, what the blocking and bridging do is create a lateral connection between your floor joist. And this seemingly simple addition offers 3 key benefits. Number 1, increased stiffness. By connecting the joist laterally, blocking and bridging distribute weight more evenly across the floor framing system. This reduces individual joist deflection or bending and effectively minimizing that bouncy feeling. And this one definitely works well in new construction. Number 2, preventing joist rotation. This would basically reduce or eliminate the amount of twisting or rotating under a load. Another common cause of instability and that often irritating noise of a squeaking floor. Number 3, improved load distribution. When a heavy load is placed on one joist, blocking and bridging often help transfer that load to adjacent joist, creating a more stable and balanced floor. So what does all this mean? Basically, by blocking or adding bridging to an existing floor, you're going to stiffen it up. There's no doubt about that. However, I don't know if it's going to prevent it from bouncing anymore or from sagging. And to address these issues, we're going to have to take a look at 4 more things. Number 1 on the list, and the most common problem you're going to have when dealing with sagging floors or any other issue you're going to have with a floor, is usually going to have something to do with number 1 on our list, and that's going to be undersized joist. Number 2 will be foundation settlement, causing uneven supports. Number 3 on the list will be damage from moisture or pests like termites that often weaken the wood. And number 4 might have something to do with the structural beams that are supporting some of these floor joist loads. Another thing you need to consider is just how badly damaged are these boards, and will you even be able to add bridging or blocking to them in the first place? And I think for those of you who have a slight bounce in the floor, and it is not sagging, and the foundation isn't damaged, and you're not dealing with termites or moisture issues like wood fungus, then I would definitely try adding the blocks or the bridging. And if you can't make your mind up on whether or not to add the blocks or bridging after watching this video, then maybe consider this. Installing a row of blocks usually isn't going to cost a lot of money, and in my opinion, you'll actually be strengthening the floor. So why not try it? And if it doesn't work, you're not going to be out very much money. Here is another question from one of our viewers. They wanted to know how you could transfer a load using squash blocks if the joists are running parallel to the walls below. And even though I couldn't find any information about it, I did find a picture on one of the joist manufacturers' technical websites and found this method here. You're just simply going to use a web stiffener and a 2x4. You're going to cut the 2x4 a 1/16 of an inch taller than the floor joist. And I think this could cause squeaking. And in my opinion, now keep in mind this is just my opinion, I would make the blocks even with the top of the floor joist. But I'm not the manufacturer, so make sure that you read the installation instructions from the manufacturer of your floor joist. And like I said, they are suggesting that these blocks need to be a 1/16 of an inch taller than the floor joist. And I'm not going to go over the nailing because I already made a video on this for joists that run perpendicular to the wall framing. And to make it easy for you, I'm not going to make you look for the other video. I'm going to add it to this video, making it the second part of the video. So make sure that you watch that also. Now, if you don't want to do this because you're worried about floors squeaking, then simply frame the wall to where the top of the wall is going to be even with the top of the floor joist. And the only way this is going to work will be if this wall is a load-bearing wall and has a footing underneath it, which is what we have in this video. Keep in mind this is just another one of our home building projects, and you can find links to those at our website by simply clicking on the home building tab. It should be on that page. This is the first video in a series that I'm planning on making to provide people with more information about details that might be provided to you in a lumber manufacturer's assembly catalog. And in this video, I'm going to be talking about the truss joist from Weyerhaeuser and how you might use squash blocks or regular blocks to transfer the load from a wall above. So this would be a wall that's sitting directly above the lower wall, along with what the manufacturer suggests you could use. Keep in mind that a structural engineer could provide you with different details altogether. So in our first example, we are going to use the truss, the TJIs themselves, and cut them into blocks. And even though I couldn't find any information on where the blocks need to be located, I like to line one side of them up with one side of the wall framing. And the reason for that would be to provide the electricians or maybe the plumbers with some spots they can drill their holes through without damaging the blocks. And another example would be to add web stiffeners. And I will provide you with nailing information in the second half of the video. Now keep in mind that there is usually going to be a gap in between the top of the web stiffener and the bottom of the upper cord. So they will be tight on the bottom. There will be a gap here. However, that gap will vary depending upon the joist you are going to be using. And I'll provide you with a little more information about the web stiffeners in the second half of the video. In the next method, we will be using the 1 1/8" rim board provided by the manufacturer, along with the web stiffeners. Now keep in mind that you do not want to use construction standard lumber here because it could shrink. And another option might be to use laminated strand board, sizes between 1¼ and 1½ thick. Next up, we're going to use 2x4 squash blocks. And if you have a 2x6 wall, you're probably going to use a 2x6 along with the web stiffeners. And I do remember installing these years ago without a web stiffener. And I only used one on one side. I did not have them on both sides. And even though I couldn't find that in the installation instructions, that might be another possibility also. And the squash blocks need to be a 1/16 of an inch taller than the floor joist. And even though I couldn't find any information on that, my guess is that it has something to do with the construction standard lumber shrinking. And even if that isn't the reason why, it might not be a bad idea to use kiln dried lumber for your squash blocks. And I just threw this one in here. I did not find this assembly method in the product information from the manufacturer, but you can see the 1/16 of an inch taller squash block here. And there's a good chance it's going to be taller than the other materials I mentioned for the blocking. And the manufacturer also suggested using solid blocking underneath any type of structural post that is going to be transferring loads through the walls. And even though I'm showing you a section of the post here that's the same size, the manufacturer is suggesting that you can use multiple squash blocks just as long as they fill the area under the post. And if we move the post over something like this, then we're going to need to use blocks on each side. And don't forget that even though I'm not showing it in this example, if you have a support post transferring a load through a lower wall, then there's a good chance you're going to need a post in the lower wall along with a footing to support the post in the building foundation. Next up, let's go ahead and take a look at the nailing for the squash blocks, where the manufacturer recommends using a 3-inch nail to attach the block to the upper and lower flange. And even though you might be thinking about making it a little stronger, I know you construction workers out there who want to just throw a few more nails into everything, then I would suggest avoid doing it unless you find something suggesting that the manufacturer allows it. And the manufacturer recommends using a 2.5-inch nail that will be slightly angled, one on each side, going through the bottom flange into the top wall framing plate. And we will also be using 3 2.5-inch nails to attach the web stiffeners together. And it looks like the location of the bottom nail needs to be 1 inch above the bottom flange, and the upper nail needs to be 1 inch below the bottom of the top flange, and then you would center this nail, and it looks like these nails would center over the wall framing, and these nails will need to be clenched or bent over. And there is also a minimum width requirement, and it looks like that's going to be 2 15/16 of an inch. I don't know why they just couldn't have made it 3 inches, except for the 560 joist series. And even though I didn't find a lot of information on how to attach the blocks that will be cut from the truss joist to the truss joist, I would imagine that face nailing like this would be fine, or toe nailing. I'm just not 100% convinced that you can't damage the flanges, the upper flange or the lower flange, by driving a bunch of nails in them. So you might want to limit the amount of nails you use, unless you can figure out exactly where it's mentioned or specified in the installation instructions or by a structural engineer while connecting the blocks to the flange. And I did find a video from Weyerhaeuser suggesting that 2 nails will be fine to attach the bottom flange to the wall framing plate. And for the solid blocking, we are going to have nails going through the wall framing plate into the blocks, and I believe they are spaced 12 inches on center. There's a good chance you're also going to have 8 D nails 6 inches on center, attaching the floor sheathing to the blocking, which tells me that we don't really need to get too carried away with the nailing of the blocking into the top flange, where the nails could actually split the top flange, because the floor sheathing and bottom plate wall framing nailing is going to help to connect everything together. And even though the other blocks only had 2 nails in them, I did find something suggesting that you might need to use 3 nails in this area, or have them spaced 6 inches on center. Next up, let's go ahead and take a look at nailing through the web stiffener into the blocking. And even though I couldn't find something like this from the product manufacturer, it seems like it might do a better job than nailing through the upper flange, along with toe nailing the blocking into the web stiffener. But again, I couldn't find any information on this from the product manufacturer. I'm just kind of throwing this out there, along with a toenail like this going through the block into either the upper flange or the web stiffener. And here's an example of what I'm talking about. If you're going to use 4 toenails to attach the blocks to the top flange, I think something like this is going to split the flange. In this video, we will be trying to figure out whether or not you need a building permit to build a shed on your property. And before we get started, you need to know that your building department is going to have the final say, not this video. So you can stop watching the video right now and contact them to find out if you can put a shed in your backyard without a building permit. However, there are a few general rules that apply in most areas. And number 1 on the list will be the most common one. If your shed is 120 square feet or less and does not have a permanent foundation and is not taller than your house, and in some cases where you have a homeowners association, it might not be able to be taller than your fence or viewed by your neighbors, then you can usually build it on your property. Next up on the list, if you have any plumbing, electrical, or mechanical systems like HVAC, heating, ventilation, and air conditioning, then you will more than likely need a building permit. Next up, let's take a look at the location of the shed. Some planning departments will require them to be located a certain distance away from your property line, and I will not be able to provide you with that information. Next up, the portable shed myth. If I can take it apart or if I can move it, then I might not need a permit. And this might not be true either. So I think the bottom line here is that if you can take the shed apart, or you can relocate it to a different spot on your property, and you're not spending a lot of money on this project, then you probably don't need to worry about a building permit, because if you ever get caught, you're going to be able to remove the shed from your property or relocate it to a different spot on the property. However, if you're going to be spending a lot of money, or you're going to have a permanent building foundation, like a concrete foundation, or you're going to install electrical, plumbing, or heating and air conditioning, and it's not going to be cheap to move this thing, then you should definitely contact your local building department or planning department for more information about the property line setbacks and building permits. Here is another helpful tip for anyone out there who can use prefabricated stair stringers for your project and are looking for a few ways to save a few dollars. And that would be to go down to your local lumber yard and purchase some lumber that you're going to use, like some 2x12s, along with one prefabricated stair stringer that you can use for a pattern. So if you're having a difficult time figuring out how to lay out a stair stringer, then go down to your local lumber yard and purchase one that you can use as a pattern. And of course, this is only going to work if the prefabricated stair stringers are actually cheaper than the lumber. And if you don't want to purchase one of the stair stringers, then take a pencil with you down to the lumber yard and then trace your own pattern onto a piece of lumber you're going to purchase. And you might consider asking the people who work at the lumberyard or home improvement center if you're allowed to do something like this. Otherwise, you're going to have to purchase one of the prefabricated stair stringers. And then simply purchase that piece of lumber and then go home and make the necessary modifications, or cut this stair stringer out and then use it as a pattern for the rest of your stringers. Here is another tiny home building video. We're going to add a single car garage to the 2-story tiny home, and this will provide additional lateral structural support to the small home. And our garage is going to be 12 foot wide. You can always make it smaller or wider. And the slope of the roof is realistically going to be determined by the roof rafters sitting on top of the wall framing base plate for the second story. So you can see the rafters sitting on top of the base plate. You can always use a ledger to change the roof pitch if you want to. Simply nail a ledger to the wall framing. Our rafters are 2x8 and they are spaced 2 foot on center. And they are shaped down here at the base so that we can use 2x6 fascia board. And a lot of times if I'm going to use 2x6, that's 5.5 inches wide, I'll shape the rafters over here to where they're 5 inches wide. I don't need to go 3.5 inches on this if I'm not going to be installing any soffit materials. And you can always run the backing board all the way over to here if you want to. And of course our blocking. And you're going to need to install drywall backing here, ceiling backing if you're going to be drywalling the ceiling in the garage. Don't forget this is going to be a 1-hour firewall here. It's going to require 5/8 Type X drywall, the entire length of this wall here. And our blocks here are going to nail to the wall framing, and this is going to create a nice connection from this side of the building to this side of the building here. And don't forget to put some type of a moisture barrier building paper behind the fascia board here to prevent water leaking into that area. And of course our backing for the fascia board, it's a 2x4. And even though we don't need to have this rafter sitting on top of the base plate here, we can always stop it right here. But I went ahead and did it anyway for this project because what I want to do is install the roof rafter first and then build this wall, because I think that's going to be easier than trying to shape the wall to fit. And I've done that before with great success. So remove our backing there. You can see right here where the rafter is fitted into this area here, and our wall framing stud is now sitting on top of the rafter. And next up, let's take a look at the blocking here and the roof rafter. We're going to have a seat cut here, and I would recommend the seat cut for full bearing, even though I understand it's going to be a little bit easier to simply set the rafters on top of the base framing plate. And I really don't know if that's really going to make that big of a difference on a project like this one here. And to provide you with a different example here, I went ahead and ran this block all the way through and then shaped the roof rafter because the wall framing really wasn't in the best location for the roof rafter. And to provide you with an idea of what it would look like if you were going to use a ledger here instead of having the rafters sitting on top of the base plate. Maybe you want to raise it an inch or two or lower it an inch or two. Next up, let's go ahead and head to the end of the building here to provide you with a couple of more views of the blocking. Now keep in mind that this blocking here is also going to provide us with perimeter roof sheathing nailing. And of course, the ledger would do the same thing also. Next up, let's go ahead and provide you with an example of how I would build something like this to prevent doing any complicated math for these rake walls or creating any problems for them fitting together well. And you might even have a difficult time framing them without a completely flat surface here. So I would build this wall first, brace it up, make sure that it is nice and plumb in every direction, and then I would build my roof. Now you don't need to build the entire roof if you don't want to. You could simply install this roof rafter and this roof rafter here, and then build the other two walls. So wall, roof, and then the walls. And then we're going to run our fascia board, sheathing, and we are done. So hopefully I've done my job and provided you with something you might have actually learned, or at the very least, another way you can add a single-car garage to a tiny two-story home. In this video, I will show you how you can actually create a pattern for a rafter by simply setting it into a certain position and then tracing it. So this isn't going to require a lot of complicated measurements, and you're not even going to need to know what the pitch of the roof actually is, but you will need to have a couple of starting points. Now, I actually went into a store by my house that had a patio roof built like this coming off of the building and thought that the information in this video might be helpful to some of you. So here's basically what I would do if I didn't know what the roof pitch was and I didn't want to calculate the length of the rafters or do any stuff like that. I would just simply attach a board about an inch below the top of the beam like I've done here. And you can use nails or screws. And this is just simply going to be something that we can rest the rafter on. And you can do this by yourself. You really don't need any help. And if you want to make the seat cut smaller or longer, just simply lower or raise this board to make the necessary adjustments. So after you've put it in place, just simply attach it to the ledger. And I've done that with a screw. Again, you can use a nail if you want to. And it's not too difficult to figure out what we're going to do from here. We're just simply going to trace the top of the roof rafter and then go down to the bottom and trace out the seat cut. So not too difficult. And next up, I've got to mention this problem. I've ran into it before. I've actually cut a pattern like this that worked at one end, but it didn't work at the other end because either the ledger was out of level or the beam wasn't parallel to the ledger. And to do this, just simply grab your pattern and move it over about 4 feet, or go to the center of the beam and then go to the other side of the beam. Or if you're using expensive lumber, cut one rafter at a time and then make the necessary adjustments if there are any. And if you run into a situation where the seat cut is a little further away from the beam, or you have a gap in between the top of the rafter and the ledger, then you can make the necessary adjustments with your pattern. So for example, if I had a 1/2 inch gap between the face of the ledger and the face of the rafter, then I would just simply lay my pattern on top of the roof rafter I was going to cut. Remember, we're going to use this as a pattern here. And then just simply add a 1/2 inch to this part of the roof rafter. Make the roof rafter a little bit longer. And of course, if it needs to be a little bit shorter, just simply measure the gap between the seat cut and the beam and then remove that from the top of the roof rafter. And of course, if you have a situation where the ledger isn't up against the wall, it's not going to be as easy to trace it as in our first example. Then all you need to do is attach this board to the bottom the same way you did before. And then grab a piece of lumber you're going to be using for a pattern and then position it something like this. And again, we can use a screw or a nail to attach it to the side of the ledger. And don't forget that this part right here, the top of the roof rafter, needs to line up with this point right here on the ledger. And you might need to use a straight edge or something like that to get that to work out for you, because you can see here that you're not going to be able to line it up with the gap at the top. And another tip I'd like to throw out there is you could always just cut a random cut on the rafter pattern, and then that might make it easier for you to line this part up with this part here. And then just grab a 2x4 or a 2x6. You can always use a measuring tape if you want to. And then you're going to use this right here to draw the plumb cut line on the roof rafter pattern. And then take the rafter down and cut it. I have it in place here so you can get an idea of what I've done. And I haven't traced anything or cut anything at the bottom yet. And then after we've made the cut, we're going to reposition it. And this might require a block here if you're working by yourself. If not, somebody can hold this at the top in this position here. And don't forget, if I was to move this over to here, it's going to be out of square a little bit. I'm not about to suggest you're going to have a problem with it, but I wouldn't do it that way. And now you can go ahead and trace the bottom of the seat cut to create your roof rafter pattern for your patio or whatever else you're going to be using this particular method for. Here is another small home building project, and this time I actually found a set of plans, and you can go download those plans. I will put a link to that in the video description box. And they have different building plans for small houses like these also you might want to check out. And these look like they're pre-approved plans. However, it looks like there will be no liability from the city or the county or even myself, because I'm just providing you with an example, and they are providing you with a set of plans that might actually need more details, more information, and approval from other building authorities. So again, I will not be providing you with any plans, and if for some reason you cannot download those plans in the future, then you can simply look at this as another educational video about home building. So let's go ahead and get started with our small house. We have a bathroom here, closet, small bedroom, living room, dining room, kitchen, washer and dryer. And we have 2x6 walls all the way around the perimeter, along with a 2x6 plumbing wall. And my guess is you can have all of this 2x4, including this wall here, if you're building a project that did not require thicker insulation on the exterior walls. And in this video, I'm just going to run through it. I will be breaking it up into sections. For example, more information about the foundation, the framing, and the roof trusses. And even answer some of your questions if you have them. Feel free to leave them in the comment area, especially if you're having a difficult time with something you see on the plans that you might need a little more information on. And here we have a piece of angle iron that we are going to use to stabilize this wall here. And in some of my videos, I pointed this out before, and this was not in the set of plans. I do not remember it being in the plans. And you might need to adjust the rebar along with install a concrete footing. And we are going to have sand over a vapor barrier along with our anchor bolts. And the size of the anchor bolts are going to be on the building plans. And I will also try to install the plumbing here if there's an interest. Next up, let's go ahead and throw the trusses on there. 2 foot on center, 4 and 12 pitch. And of course, this does have a detail. You can take a look at it. And it looks like some type of a fire-rated detail, something to slow the fire down. Fascia board, of course our outlookers blocking, all of our backing for our drywall. And of course we have an access hole for the forced air unit if you're going to use one in the attic. If not, don't forget you are going to need access to an attic in a situation like this. And like I said, this is just the first part of the video. Make sure that you get your plans if they are still available, because even though I'm allowed to download the plans, I'm not 100% sure I'm allowed to give them to other people. And thanks for watching. If you enjoyed the video, let us know by hitting the thumbs up button or letting us know in the comment area.